What I love about your guys' panels is how much space is inside them. As you guys can see here, how clean they are, color coded, all labeled one by one. And this is important when you dive into new systems, say like this Pro Refrigeration system, Pro Green system, is that you need to get into the electrical wiring diagrams and you got to follow that stuff, because we're going to get into the safety devices today and how the refrigeration controller works and things like that and troubleshooting this stuff. But you as a technician in the field, you want to go in and follow all this through their electrical wiring diagram. This is exactly what we've been training a lot of the pro dealers on, walking them through step by step, because one of the biggest things, it's usually not the control issue, like the programming issue. You know, that programming is done 99% of the time by the manufacturers, and maybe adjust it a little bit for a specific application. If you're up in Alaska versus down Southern California, there might be a little bit changes. But besides that, all the wiring is going to be on the wiring diagram. You got to dive into that to follow while you're troubleshooting properly. Just don't be winging this stuff. You got a nice panel there, all with the labels. Follow the label. So welcome everyone to another CO2 Experts Live. As always, having the top experts from around the world come in and chatting with us, sharing their in-depth knowledge on CO2, which is amazing. I'm super blessed to have friends from all over the world to come and share their in-depth knowledge. And today we're going to be diving into troubleshooting transcritical CO2 chillers with my good friend Damon Reed from Pro Refrigeration. We've been working together for quite a while. We actually do some exclusive and private training programs, Refrigeration Mentor and Pro Refrigeration partnering together to do some stuff. So we'll talk about that later. If you're interested, you're going to reach out to Pro Refrigeration and talk about these training courses that we do. But I'm super excited to dive in today because Damon is such a wealth of knowledge. And every time we talk, I talk with him, I'm learning something, which is always awesome. When you're working with people who know more than you is probably the best. That's for me. I'm trying to find people from around the world who know more than me, so I can absorb their knowledge, really, so I can share it with the world to really help uplift the refrigeration industry. Damon, welcome to CO2 Experts. How you doing, brother?
Hey, I'm doing great, Trevor. Thanks for having me. I appreciate you putting this together and getting us invited. Hello, everybody. Appreciate the great introduction. I get questionable sometimes on whether I'm smarter than anybody. I think I just this is just happens to be one of those things I like to geek out on, and I think that's the fun that Trevor and I always have when we do get to having discussions together, is talking about all the different scenarios and things like that. It's fun to have the engagement. Really happy to take the time to go over things with everybody and give you kind of a breakdown of what we're going to be talking about today in this session. I put together kind of a 3-part discussion for us. We're going to talk specifically about a transcritical CO2 chiller system. Pro Refrigeration, we manufacture the Pro Green solution CO2 system. What it is it's a 100 horsepower, 2 by 50 horsepower compressor transcritical CO2 system. So I utilize heat recovery on the unit. We have air-cooled gas coolers. We now have adiabatic options for those gas coolers as well. But it's a packaged unit, so it includes the glycol reservoir. It includes all of the refrigeration components and controls. Everything's packaged onto that single skid. We're going to go over the components. We're going to go over order of operations. And then we're going to go over some remote diagnostics tools and their capabilities. And as we move along, as I'm sure Trevor and I will have discussions and engagement. If anybody has questions, please definitely keep the questions rolling. We'll make time to be able to address any questions that we have.
Yeah, so if you're here on the live session, throw it in the chat. If you're listening on the podcast or in a YouTube like Spotify or Apple, put it in the comments below. We'll get to those questions because we want to help you grow your knowledge. And if you're listening to this and you don't understand what's going on, go to the YouTube channel and go down in the description and the link will be there, and come and watch the slideshow and the videos.
Great. So I'm going to talk about from the component standpoint. I wanted to break it down at a controls level, and then I wanted to ID the controls on the system, then go into safety devices, because as we're doing troubleshooting on equipment, these are the things I find that if I can identify the major electronic controls components Then I know what the safety devices are. I know what the order of operations is expected to be. Now I can start to put things together when I'm in a troubleshooting diagnostics phase on the equipment. So we utilize the Danfoss refrigeration control components. We use the system manager, which is up here in the top left. This is on the front of the electrical control screen. Kind of over my shoulder, you can see I've got a front end picture of a Pro Green unit. So on the one side, there's the 850 HMI. We have that in a completely watertight sealed enclosure cover, but it's clear plastic, so you could still see the HMI face. That's talking internally into the control system with the refrigeration controller, which is the 781. It's talking with the evaporator controller, which is the 750. And it's talking with, it's our circulation pump controller, which is the 205. Those three are all talking together through a communication bus back to the system manager. So those are the kind of the main components I wanted to identify. So the 781, this whole top section consists of the 781. We've got expansion modules that we include just to give us the extra IO that's needed. The 750 controller is down in this area here, and the 205 is down here on the far right. It looks a little bit like if you were to go to, say, Danfoss's website and look at the 205 or the 781 or the 750, you're going to see like this main controller. You might not see the expansion modules added. So just kind of shows the added flexibility of what those controls features are.
What I love about your guys' panels is how much space is inside them. As you guys can see here, how clean they are, color coded, all labeled one by one. And this is important when you dive into new systems, say like this Pro Refrigeration system, Pro Green system, is that you need to get into the electrical wiring diagrams and you got to follow that stuff, because we're going to get into this the safety devices today and how the refrigeration controller works and things like that and troubleshooting this stuff. But you as a technician in the field, you want to go in and follow all this through the electrical wiring diagram. This is exactly what we've been training a lot of the pro dealers on, walking them through step by step, because one of the biggest things, it's usually not the control issue, like the programming issue. You know, that programming is done 99% of the time by the manufacturers, and maybe adjust it a little bit for a specific application. If you're up in Alaska versus down in Southern California, there might be a little bit changes. But besides that, all the wiring is going to be on the wiring diagram. You got to dive into that to follow while you're troubleshooting. Probably just don't be winging this stuff. You got a nice panel there, all with the labels. Follow the label. So I love it.
Yeah, I agree 100% with you on that, Trevor. And also I would point out, when we factory test run all of these systems before they ship into the field. That's one of the first things when something arrives in the field that we require is go through all the electrical connections, make sure nothing got loose in transportation. Loose wires can pop up down the road. And, you know, you might look at it as a technician and dive right into, you know, I've got these big black boxes that I don't really fully understand. So it must be something going on there. You know, there's a bank of ice cube relays over here on the side. Sometimes, the majority of the time, there's nothing wrong with the controller. You got an ice cube relay that's not getting the right voltage. Or I'm just going to share some examples. I've had communications alarms that were intermittent and pop up from time to time. Well, on the 781, if you notice right here in the front, this is the communication bus where it makes the connection. So it makes this connection from the 750 is here, and then this follows the raceway up to the 781, and then that's then fed over to the 850. Well, there was a one loose wire on the 781, and it was given kind of intermittent communication alarm emails that we were receiving. So we were able to example on that, or not example, but we were able to identify that with the technician in the field. Like, we probably just have a loose wire. It's not the controller's bad.
Yeah. And I see this time and time again too, Damon, and we talk about it a bunch of times, is like the easy stuff is the hard stuff. You know, so going around and tightening every single wire, like there's could be hundreds to thousands of them on some pieces of equipment, but that's part of our role as a startup or commissioning technician, as well as even
Yep.
a service technician. These are the things that we need to go to during the maintenance and get out there and do the stuff. And it's boring, it's repetitive, it can be tedious. You got to do it safely. But this is some of the things that most of the times it's that. And one of the quick tip would be with the new tools, and I know we talked about this before, is a thermal imaging gun. So you go up to that panel and you see it's really hot on a couple of wires or on a contactor or something. There could be a loose wire there causing it.
Yeah. From a tool standpoint, I mean, FLIR makes a thermal imaging camera that plugs into my cell phone, into an iPhone. You just pop it into the bottom and you can look at it, look at stuff. You want to have a baseline picture is what I found. If you have a baseline, then you can see where you've got hot spots, but it's definitely, those are tools to keep in the tool bag and utilize them when they're available. Using the tools that are available is real important. And we'll talk about that later in the end on this too. So on the controls, the other items I wanted to talk about were the safety devices that are in the system. So we've got like the refrigeration control scheme or refrigeration controls identified, and the evaporator control and the circulation pump control. But what about the other safety devices that are in the system that could open from a failure condition and require to be troubleshot? Just because the controller is saying, hey, my compressor's off on a safety relay. Well, what is feeding that safety relay? Well, the things that are feeding that safety relay would be like, we've got an oil regulator, we use the OLC oil regulator. It's mounted into the side of the compressor. It's got a little series of lights on it. If it's green, it's happy. If it's not green, it's not happy. That's the simplest way I can describe that. There is a sight glass on the front of it, so you can monitor the oil level. But the oil regulator does have a little float that extends into the crankcase of the compressor. It makes a decision on whether it needs to let more oil in and keep the oil balanced. If you've got a good oil level on the sight glass and your float's happy, your oil switch should be happy. Green is good. We monitor the oil pump side of the compressor. That's just a Delta P2 differential oil pressure control. So it's monitoring, hey, when this compressor's running and it starts, I need to start looking at net oil pressure. And is my net oil pressure good enough to stay running, or is it not? This has a little LED on the backside of it that'll light up red. That can be a little misleading because when the compressor's off and it's not getting a signal, that'll show up as red. It also shows up as solid red when it's in a tripped condition. This white cap that you see here, it's soft. You push, you don't want to push on it, hit it with a screwdriver. It's a little sensitive, but you just push on it with your thumb. And while you're holding it down, the little LED is going to blink, and you hold it for 5 seconds and then you let go. It'll blink rapidly while you hold it down. It'll blink slow when you let your thumb off of it. And it's going to go into a time delay. So it'll go for 120 seconds, and then it'll make a decision. Hey, do I start, or do I have a sensor failure and I want to start up again? If you walk up to it and it's just flashing rapidly, that's telling you that you've got an oil sensor issue. So something's not happy with the sensor. On the oil reservoir, that's what we distribute the oil to both the compressors in. The 250 horse compressors are parallel pipe. We have an INT 276 that it's just a prism that monitors the oil level in the oil reservoir. So if the oil level drops to this level, it's not going to shut down the equipment, but it is going to give you a low oil warning light on the front of the system. Just means, hey, I look at my oil system. I may need oil. Where did the oil go? You kind of go into your troubleshooting steps at that point. And then inside of the compressor electrical box, we have the SEB5 thermal overload. So it's monitoring the thermal temperature on the compressor motor windings. If the windings get warm for whatever reason, that's going to go ahead, that's going to open, trip, and you do get a red indicator light on the front of the compressor electrical box that we install. You push that button down, hold it for 3 seconds, it drops power. You let go, it'll reset if the thermal condition is no longer present.
And this stuff is key. So what Damon is talking about here is stuff that we've talked about before in our previous podcast, as well as most refrigeration systems have components like this. And this is why he's talking about it. It's so important to understand how each component works, because usually if something's you're there servicing or troubleshooting, it's one of these broke. You know what I mean? And I don't mean broke as in fail, but it broke the chain of command, which we're going to talk about here in a minute, because there is a sequence of operation on how each one of these safeties work and why we have these safeties in a system just like this Pro Green system, really to notify us as technicians on what is going on. So it's really, really key to understand how each component works.
That's right. So we get into some of the safety switches, and on the power side, circuit breakers. You know, we've got two control panels. The one that has our main power input, that's where we're going to have circuit breakers. We're going to have contactors, but motor overloads. You know, now we're just monitoring fluid pump motors, and those overloads are set up. They're bimetal resistors inside. If they sense too much amperage for too long of a period of time, they're going to trip, and they're set up for a manual reset. There's a reset button right below where my cursor is showing now, the red dot. There's little blue buttons. If they need reset, there is a trip indicator under the plastic piece right here. I know it might be a little hard to see with the size, but I don't typically rely on those very often myself. It takes just a second to hit the blue button, and if you hear a click and it reset, then I know that's my issue, and I've got my amp meter out and I'm checking amperage. We also have the high-low pressure safety switches that are monitoring suction and discharge pressure. On our systems, we mount those directly behind some suction and discharge pressure gauges that are just some analog gauges we leave. Those gauges they're not like consistently calibrated. They go through shipping. It's a tool that we add to the equipment to help make diagnostics a little better. If I was trying to do some diagnostics where I wanted to test the accuracy of a pressure transducer, I wouldn't rely on those gauges. I would rely on my own set of transcritical CO2 refrigeration gauges that I service equipment with to get some verification.
And I totally agree with that. There's new tools out there too, so you can have service tools. Because I know your team travels around the country, so some of your service guys could be flying, 1,000 miles. So you can't bring all your tools with you. You got to be selective about it. So there are new CO2 tools, like little gauges that can go up to 5,000 psi. Look this stuff up so you can have a travel toolkit, as well as the motor overloads. I like you bring that up. You got to make sure they're set properly. You got to go look at the motor, what's Correct. The service factor on there, and make sure that you match that up, because somebody could go and start playing around with that. And this is why it's tripping, or it's actually tripping for a high load situation where you are overamping for certain reasons. And this comes back to you troubleshooting that system and understanding it. So don't just go and reset stuff before you understand the plan of attack. This is what I talk about in all my programs. If you see something trip, like we talked about before, the Delta P, for an example, you don't just go and reset it without thinking, what am I going to do? My gauge is already hooked up to check the pressure differential, things like that, So I love those points, Damon.
Yeah. So that's just kind of in summary with the controls before we jump into the order of operations. So we've got our electronic refrigeration controls. We've identified those. We've identified our safeties. Now what we're going to talk about, we're going to jump into the order of operations. And the order of operations is really broken down at its simplest level, okay? Because I think it's very common for us to want, as mechanics, to want to jump into the difficult side of things. Well, how's the high pressure valve being controlled? What's going on with my flash gas bypass valve? Some of these things, and it's you need to know that, you need to be aware of that on the back end. But the main things, if you can just burn into memory the order of operations, we start the circulation pump based off of the temperature of the glycol reservoir. We use a calculation for that. That's part of the control software. So we're monitoring the glycol reservoir. If an example would be if the glycol temperature gets above 35, I turn on the circulation pump. Once I turn the circulation pump on, that's sending a signal to the 750, which is the evaporator controller, and it's saying, hey, guys, I'm running a pump. You should start making an adjustment with my valves. So start waking up valve A and valve B in an injection mode. And I say that because anyone that's familiar with the 750 system, you can go in and the control side, and you might find section A or section B thermostat. But if you're going to make adjustments and you want to do some control based on the superheat control, you want to go to the section A, section B injection control side of the system if you're using store view, and we'll look at store view later. So circ pump starts, 750 says, oh, I got to do something. I need my valves to start operating. The valves start to move, they start to open up. The next thing that is expected to happen is my suction pressure is going to rise. Well, as my suction pressure rises, now my 781, which is always monitoring that, my refrigeration controller, it says, hey, what suction pressure is coming up. And it waits to start a compressor. If that suction pressure gets to 400 or above, then it goes ahead and it starts a compressor. It's not going to, I mentioned earlier that our Pro Green system is 250 horsepower compressors. They're in parallel. They're both VFD controlled. We're not going to start both compressors at the same time. We're only going to start one. The 781 is what's driving that signal to those VFDs and saying, how much compressor capacity do I need? That is based off of what my suction temperature requirement is, not my suction pressure to just start like a cut in, cut out. My actual ramp up of capacity and ramp down of capacity is dictated by my actual suction temperature. So evaporator's on, valves are moving, suction pressure comes up, I hit 400 PSI, my compressor starts. If my suction pressure drops down to 250, that's my cutout point. I shut my compressors off. So I talked about, I added in like the compressor control. That's one of the things I didn't really get deep into, like the medium temp capacity control. I'm not getting deep into flash gas control, my high pressure valve control, my heat recovery control. All that's still happening off to the side. But at its simplest level, I've got circ pump starts based off of temperature. That wakes up my evaporator. That then turns on my refrigeration control. This is how I get a compressor and expect to see a compressor operating.
Yeah. And this is so important, understanding the sequence of operation, order operation as a service technician out there working on any CO2 system, and is knowing those stages, because what I said earlier is that if something's not working or running, something's broken along that chain. For example, we just talked about those safety controls. All of a sudden, if it goes through the sequence of operation, just like Damon talked about, the reservoir temp increases and the circ pump start and the EEV starts and suction pressure rises, but all of a sudden the compressor don't start and it goes off on compressor proof because maybe you have a pressure issue. It could be an oil issue. It could be one of many things, internal temperature of that compressor, that stator's too hot and it's off on the SE controller, SEV5, overload control. So these are some of the things, when you know the sequence of operation, is going to make your life easier and quicker to troubleshoot a system.
Oh yeah. Yeah. You'll just look at your pressures, is what I do. I look at I know in the back of my head at 400 PSI, this compressor should be running, whether the 750 is on or not, because the 781 is always watching that pressure. If we come up above 400, that compressor is going to start. If it's like in an off cycle and we're getting some increase in pressure just based off of ambient conditions, it should still pull down and operate it back down to hold it between that 250 and 400 range. But if I'm sitting there watching a system and, a common call I might hear is the compressor's not starting. Okay. Well, are there any active alarms? No. Okay. What's your suction pressure? 350. Okay, well, why is our suction pressure only 350? Well, I don't know. Well, that means either let's backtrack in the circuit. What's our flash tank? What's our flash gas bypass valve doing? What's our 750s doing? Are our valves even open? What is the temperature of the fluid that's running through my evaporator? Is it a lot colder than I think it is? Those are the things you start to drill down once you've got this. But I always start with this order of operations. This is constant. And I always come back to it because before I want to jump off and get into the more complicated diagnostics, it's really important to just focus on this simple order of operations.
And what I like about that, we talk about this all the time. Us as technicians, even us, we talked about in the field, we'll go in and it's like this biggest problem and it has to be something advanced problem. 90+% of the times it's a basic issue. It's something basic that's happening. You got a dirty condenser, you got a sensor that failed, a transducer that failed. It's not, it's not like, well, it could be a leak, but it's not something that is usually an advanced troubleshooting problem. And
Yeah. Well, when it's a leak, Trevor, when you've got a leak, your system pressures tell you that, everything. Let's say I said earlier, if the compressor doesn't start and suction pressure is only 300 psi, well, what's the rest of the system pressures? Oh, geez, I've got 300 psi in my flash tank. I've got 300 psi in my gas cooler. Like, wait a second, how come? Why is all that so low? And so then you start looking into deeper, like, well, maybe I've got a loss of refrigerant somewhere.
Yeah.
I think although we're talking about, and we're geared towards this being transcritical CO2 chillers, these are all things that we troubleshoot on refrigeration systems all the time, whether it be a synthetic refrigerant or whether it be a transcritical CO2. It's still just troubleshooting pressure controls and order of operations all in the same way.
Yeah. And I just had a conversation with someone about CO2 and diving in, like people from all over the world. And they're like, there's just a big fear of CO2, but CO2 is just refrigeration. You understand the safety side of it. Like we even went through a little bit already, and how you guys build your equipment. There's so many safety parameters in there, safety valves and pressure relief valves. Even if something does happen, there's protection.
That's right.
Because you have to go through codes and regulations. You can't just throw a CO2 system out there. And so the fear, and I can see the fear of CO2 is dropping dramatically. People, after they get trained, they get to understand it's just another refrigeration system.
Yeah. It's the startup sequence of the equipment and the verification with this level of controls to verify everything. It's not uncommon to spend a few hours just verifying sensors, verifying the controls before you go to add refrigerant to the system. And, a lot of times, with the synthetic systems, we'd get as much gases in as we could. We'd start running and you still follow the same processes, but it's almost anticlimactic when you start that compressor on a CO2 system because everyone's so excited. Everyone wants to hear it get up and running. And then it starts and everyone kind of looks at each other and says, well, that's it. Like, yeah, that's it. It's working.
Yeah.
And I was that way my first time too.
Me too.
It's just crossing over. So crossing over past the unknown.
Yeah, exactly. And I think as we continue down this journey of natural refrigerants and newer refrigerants, even like the A2Ls and the A3s, we're going to start to see people are going to be indentured in straight away with that coming into the industry versus, you got 22, 404, 410, all these refrigerants that are becoming obsolete and phased out. I think there's going to be a less and less fear because we're just going to be all trained right off the bat on this stuff that's in there. So I'm excited.
This is the new norm. Well, so from an order of operations standpoint, just keeping it simple before I jump in and start talking about some of the remote diagnostics tools and how to utilize that. That gives us our basic order of operations, the controls. We've got the safety features. Now I wanted to talk a little bit about remote troubleshooting tools and the things that are available with the control system. So when you're doing the remote troubleshooting, Danfoss has done a really good job with their StoreView software. It's very, very intuitive. It gives a really good example and representation of like what's happening with the system. There's a StoreView desktop version, but there's also a StoreView web version. And a lot of my focus is going to be on the StoreView desktop. It's probably because that's the way I was brought up with the equipment. But there's some things that I get out of the StoreView desktop version that I like, and there's things that I use the StoreView web version that I like. So a lot of times it won't be uncommon if we're doing some diagnostics where myself and our technicians, where we'll have a split screen running and looking at them both. But you log into your system, and there's a lot of different views you can look at, and I'll show us a couple examples of the views. But my favorite view is the system view. So once you log into your system, it kind of comes up to this dashboard. And I didn't want to just show you the dashboard. I just wanted to get more into the diagnostics tools. But I like the system view. The reason I like the system view, I'm a little bit of I'm more of data-driven kind of numbers person, and I don't like to bounce around between a lot of different screens. I want to see kind of everything on one screen. And so you can see here, I'm looking at my suction. What's my suction status? In this particular moment on this system, it's normal control, meaning there's no alarms. It's okay. I've got a 20-degree suction set point. It's currently set at it's seeing 7.6 degrees. My stat. So right away, before I even go any further, I expect if my reference point is 20 and I'm 7.6, I better not be running any compressors. There's no reason for that, right? So I'm in a normal control status. My compressor running capacity is 0%. Perfect. That's what I expect. My discharge, I can see what my discharge temp is, and I can see what my suction gas temp is. Perfect. That compressor's in, it's just holding, it's standby condition. Same with the heat recovery. I get that view. I can see, hey, I'm idle. That's because my compressors aren't running. Why would I be operating heat recovery if my compressors aren't doing anything? So, status is okay. I've got a reference value of 180 and a current value. So we monitor a remote sensor. When that compressor starts, now if I'm sitting here watching it, the compressor starts, I expect this to go into heat recovery mode because I'm 130 degrees below what my reference point is, right? So the fact that that's that low, and knowing this particular customer, they're just in a down. They have hours and hours of downtime where they're not in operation. So I know that's their status. We jump over to the condenser side of things. Everything's happy. What's my reference, my current value? Same thing. I could see if I've got a bypass valve, am I in gas cooler mode? Am I in bypass mode? What's my pressure? Hey, I'm right now sitting idle. I don't mind seeing 560 PSI there. Jump over to my high pressure control. This is where I'm controlling the high pressure control valve. I've got a current value of 550 and set point 619. Well, that valve shouldn't be open at all right now. And it's not, it's off. So that's expected. Receiver control, my reference is 550. My current value is 550. My receiver OD, that's the flash gas bypass valve output. That's at 0%. Hey, it's because my receiver's at set point. I'm not generating any pressure. I'm not asking it to open up and let my receiver pressure come down. So really quick, you can take that snapshot with this view. I like that.
And I think that's a great opportunity as a technician, because you're going to get a service call or you're going to potentially dial up. But a lot of the times you'll be out there in a field looking at store view, or you're looking at the controller. More and more technician, I'm talking to them more, even in my programs, you've got to have the proper tools. And a computer is normal now in this day of refrigeration. Okay, you can go and buy them at Walmart or on Amazon for very inexpensive prices. This is a tool now for refrigeration technicians, and you might be still fighting it. I don't need a computer, or you might say, "Oh, my company should buy it." No, you should have your own computer for refrigeration. Put all the softwares you need on it. Be able to log into controllers like this Danfoss controller, as well as many others, so you can troubleshoot it quicker. Or you can use the handheld, or not the handheld, but the screen on the controller itself. But it's a tool, guys. It is a tool today, computers.
Oh, I mentioned earlier that there's the web version of StoreView. Guess what? Pull that up on your browser on your cell phone.
Yeah.
So if you don't have a computer, you've got a smartphone. You can access it through there and still be able to see some things as well. So it's just utilizing the tools that are at hand. This shows I mentioned earlier, there's multiple views. Some people like the data-driven view. Some people want something with a little more graphical representation. So up at the top of the control screen, I'm just moving something here on my end a little bit, but there is the graphical view, and there's 3 screens on the graphical view. So we give a rack view, an evaporator view, and a heat recovery view. So you would have to jump between the 3, but this gives me the same thing that I just saw earlier. If we think about it, I can see my flash tank. I can see it's 580. I know that, 550. I know that that's my control. I expect my flash gas valve to be at 0%, which it is. My high pressure valve's at 0% as well. My evaporators are off. So, this is suction superheat here, and suction pressure, suction temperature, discharge temperature, and then there's a little 0% above each compressor. It's just saying, hey, I've got 0% compressor capacity. Like, I'm off. If the system was what I do like with the graphical side is when it goes into an alarm condition, if there is one present, all of these values will highlight red. So it's a very distinct, like, hey, why is this all glowing red right now? Something's wrong. Even though the system might be running and operating, it'll still stay red if there's an alarm condition present. So I do like that.
Yeah.
This is a kind of even a further level or another layer of view. And so you go from the system view to the graphic view over to the detail view. The detail view is where, now I'm looking at my status of my suction. I can see obviously a lot more data points. You can select the summary tab and drop down. You can get into safety conditions. You can get into all these different layers of data view points, but you also get the settings tab off to the side. So if you were to drop this menu down and go into like the heat recovery view, for example, you would see the technical data on the heat recovery, and then over on the side, you would see some settings that can be changed by the user. I don't recommend changing many settings remotely or without access to somebody on site, because it is easy to make a setting change, not get the expected result, put the system into an alarm, change your setting back because you're like, okay, that didn't do what I expected to do, but now what? Now I got to get a hold of somebody. I got to have them go make a change and have some communication. So one big piece of advice I could give everybody is, if you are going to make a remote change, make sure that people on site are aware that you're going to do that, so that everyone's comfortable and prepared. If things go south, you can get things turned around real quick.
Yeah, and that's super important. Remote dial-up is amazing. This is what's great about our industry. We're going to be able to start to see more things. We got more data, because I like what you said. Data is so key for us as technicians. Before, we'd have to have 3 sets of gauges on 3 different parts of the system, and then system changes. So when you get to this other set of the parameters, if something changed, a fan turned on or off, now you can see it all in one shot. But yeah, you want to make sure if you're changing. So I love what you said there. If you plan on changing something, you got to have someone there, because you could, for some reason, all of a sudden that high pressure valve closes for whatever reason. You change something and the compressor is still running, and you may pop the relief, and now you get no CO2 in the system. You know what I mean? That could be an issue. And now, for example, your customer could be running a process and trying to cool down the milk or the vats, and they can't do it at that point. That could be a big issue, right? So
that's correct.
It's really important to have great communication. And this is what I talk about with technicians: have good communication with the people you're working with.
Yeah, that's important. So some of the troubleshooting. So I just wanted to show like the access and the views that are available. That it's a tool that you have with the equipment. But then you get into looking at some of the alarms, troubleshooting side of things. You notice at the top there's a alarm tab, and the alarm tab that gives us like a full alarm history of the system. So if you get notified that there's an alarm, from a technician standpoint, it's real easy to log in, look at the alarm history. You could look at any active alarms or what alarms were cleared, and you can see like, okay, well, what was happening upstream of the alarm? That's how I always like to look at it: is what happened before, what happened during, and then what happened after. And I don't get too deep into it. My first pass is going to be pretty fast. What happened 4 or 5 minutes before, 4 or 5 minutes after, and 4 or 5 minutes during. And then if I have questions or if I can't piece the puzzle together from that, then I'll go in and utilize the history tab, and I'll show that later in a slide right here. So the history tool, that gives you the ability to go in and you can graph and take a look at, okay, historically what had happened on a system. And this top one's an example where ultimately it was a low fluid level in a heat recovery system. So we have a closed loop charge of glycol. Well, when that closed, there was a leak on a pump seal. There was, I think it holds about 7 gallons of a glycol mix. It leaked out. So, but it affected the refrigeration circuit, or it was affecting the refrigeration circuit. So we were able to look at it remotely and say, well, man, our discharge temperature, look at it. It got all the way up to 268. And then this is, of course, we get a compressor safety trip. So now our discharge temperature comes down, it just sits idle. And then here's where we got it reset. We watched it operate. We're like, man, that's still running really high. So between this point and this point, we identified, oh, we've got to get some fluid over into the heat recovery system, get it in, and everything's running. And we're running, it was still running a little high. I think things tapered off once it got into its operation. But, we went from here to here this was the amount of time it took us to troubleshoot it at that point. We get notified, we get an assessment, then we get out on site. We say, hey, it's good let's get this thing fired up. Let's start troubleshooting. Problem identified. Now we're back into a steadier operation. So.
Yes. So I like the graph here. So definitely, if you're listening to this, go and go to the YouTube channel and watch this video. But for me, if I would have seen that, I'd be focusing on the refrigeration circuit and probably get pigeonholed on the refrigeration circuit issue. You know what I mean?
Yep.
Like,
yep.
What is going on with the refrigeration circuit? And this is the biggest thing that I see in secondary glycol systems, liquid overfeed systems, where us as refrigeration technicians, even chiller technicians, we get focused on the refrigeration circuit, but this has nothing to do with the refrigeration circuit to cause this trip. So
Correct.
So
Correct.
even doing this remotely, like you're looking at this remotely, you probably couldn't tell that's the liquid fluid unless you're there and you actually do the tests and checks and look for a leak. Why did it go off? If you're experienced now and you've seen this before, yes. But if you only worked on a 20, 30, 40 systems, you're only doing a couple of years, you may have not have seen this happen yet. And one of the things I remember used to get pigeonholed and, oh, it has to be this, it has to be this. You have to take a bigger view at a whole system, because your refrigeration circuit could have an issue because of the glycol.
I've seen where the chilled glycol reservoir is low on fluid level. It's like 50% low. And, so that's causing a low flow issue because you're getting entrained air into the pumps. And so you're not getting the right glycol flow through the evaporator. Be the same thing on an air side. If you're not getting good airflow across an evaporator, what starts happening? Suction pressure dives off. You're seeing higher temperatures on the cooling media, and you're wondering, man, why is both of these compressors not running? I'm only running one. Well, if you look at your suction temperature, it's way down. And the technician's first reaction is like, well, we've got bad electronic expansion valves. Well, why? Why would you say that? Well, the suction pressure is way low and it should be coming up, but it's not. And so then you start peeling the onion, and you eventually get into, you want to peel the onion from the outside in. You don't want to try to get into the core and dig it out. So outside in would have said, do you got enough glycol in the reservoir? I don't know. Well, we didn't check that. That didn't come up in conversation until step 10. Well, step 1 through 9, we just made sure everything was good, but it's a time factor. You're just wasting time if you just start at the basics and then work your way in. Most of the time, it's one of the basic items.
Yeah, and I totally agree with that, because there's so many times as I couldn't continue to advance in my career as troubleshooting, because I was always an average troubleshooter, but over the years, as I gained more and more experience, I started to learn not to think about the job or stress and be like, has to be the problem before you even get there, because sometimes dispatch calls you or you get a call and they say it's this problem. It's actually not even that problem when you get there. And
Yep.
so you come and then you start with the basics every time, and you'll
Yep.
learn, is the pump, circulating pump running? Do you got glycol in there? Is the fans running on the electrical panel? Because some of them, you'll have to cool the electrics maybe. You know what I mean? There could be anything.
Yep.
Could be something little like that.
Yep.
But start with the basics and take a overall look at a system.
Yeah, very, very bad. The one single message I'd leave everybody with is that just don't overlook the simple stuff. This next one down. This was an example where we had a bad discharge transducer. This was actually one where that when we were doing the diagnostics, we couldn't identify remotely any reason for there to be an alarm. We were getting the system was going off on compressor safety alarm, which was traced back to the high-low pressure switch. The high-low pressure switch, we were able to talk with a maintenance mechanic on site who was able to reset it. Well, we know when that trips, we either went above 1600 psi on the discharge, or we went down below 200 psi on the suction. And we're looking at things and we're like, we're never, here we're operating and then we trip. Well, I can't see off to the side, but I think we were like 1300 psi. We're well away from 1600. And so, the condition was present. It was reset manually on site. We operate, everything was looking perfectly normal. And then all of a sudden, boom, we trip. Now we're off. Now things have equalized. Guy goes out, resets it again. Everything's running normal. Boom, it trips again for no particular reason. I mean, we're looking at discharge temp. We're looking at chilled water sensor. We're looking at suction gas temp. So then, that's where we make the call. Okay, well, I got to get out on site. And when I say I don't mean I personally. I mean, as the mechanic, as the technician that services the equipment, go out on site, see if these pressures are right. Is this making sense? And in this case, we were actually getting up to 1500, 1600 psi, but there was a faulty discharge pressure sensor. It just wasn't reading accurately. So that you can verify that's when you make that call to get on site. So. But the remote diagnostics kind of already pointed the direction. Like, hey, we're going off on high pressure or low pressure. Let's make sure those pressure transducers are reading accurately. So on-site time was, 20 minutes, super quick to get it identified.
Yeah. And that's important, right? Understand the system that you're working on. Take a look at, it's the basic stuff. Like a sensor is a basic thing. A temperature probe is a basic thing. We just need to do the proper checks, and they're very easy to do the checks. We've talked about it in many, many different sessions.
Yeah. Setting up the email alerts. That's another thing that is very, it's overlooked. It's not done often enough, and then it can be ignored a lot of the times. It's easy to dump emails over into a junk folder or clutter or something to that effect. But, here was an example of an email that came through from a system where, we had two compressors, both trip on safety cutout, but you notice at the top, there's an external power loss is identified. Well, inside of the control circuit of the systems, we have a battery backup UPS for all of the low voltage controls. So if there's a power failure, that UPS says, hey, I lost power. I'm going into an alarm mode. Boom, that triggers an alert. Then your compressors so you imagine you lose line power. Now your compressors go to do something and they're like, hey, I ain't got the right power. Boom, I get safety cutouts at the same time. So eventually what was identified here was the on-site power had issues. It wasn't creating any trips on any other equipment, but the chillers equipment was picking it up and saying, hey, we're not going to operate right now. This is so, it went back to a utility connection issue. So
yeah,
all from an email.
Yeah. And this is something that has nothing to do with us as a technician. This has something to do, and the system itself. This has to do with the power coming into the building, so this is so important to understand how electricity works. And we should know that as technicians. You need to be following codes, national codes. You need to take training on that. So if you're new to the refrigeration industry, wherever you're at in the world, it's all about being safe. And right here, this here is where you're making a phone call to the customer talking with the customer about it, and they're calling the power company or with you together, making a phone call saying, I got my meter here, I'm going in, and this is coming straight from the line, your transformer outside into the building, and this is the power, or into the system, I guess, you know what I mean? Because it would be the wrong power into the system. And so
nothing will get your client happier than you getting in touch with them before they even know that something's happening. Say, hey, Mr. Customer, did you notice, have you guys had any power issues recently? I noticed the compressor tripped, on the chiller. And I also got a trip that there was an issue with the external power. And you're going to get, I didn't even know there was anything going on. Or you're going to get, we've been having some power issues. That's awesome that thing shuts down and you let us know, and they're going to appreciate that.
Yeah, because everything now we know is on electronics, in our houses, in our commercial buildings, in our industrial buildings, everything's electronic. So you got drives and VFDs, and all of a sudden you start having power issues. You're going to have weird things happening all over the place. And so this is something that we can help bring value to our customer, just building the relationship with them. But once again, it's about the safety. You've got to have the certificates to do this stuff. So just giving you a heads up on that. So make sure you take training on that. But that's a cool feature to have where you're getting an email. This stuff does have to be set up, but you know what?
Yeah,
it's not difficult to set it up. You get into the Dan Foss manual and you read a few pages and you can figure it out, or you can go online. They got a ton of great videos online to show you how to do this stuff set up. So
that's right.
It's important for you to learn how to do it and not always just calling support, say, can you set this up for me? Because when
we'll do, as a manufacturer, we'll do our best on the front end to collect the data for the job site to be able to input this and have that ready to go ahead of time before the system's commissioned. Otherwise, this is something that is one of the first steps during the commissioning of the system, is to get this all set up with the IT people on the job site. Yeah. It's just as important, in my opinion, as getting the mechanical system up and running. Because you get it up and running, you want to be able to get notifications or be notified if there's a hiccup. Nothing's worse than going and starting up equipment. Everything runs great through the night. You go check on it in the morning, and then you're on a plane heading home, and you get a phone call. Those are the worst.
Yeah. You land and you turn back and jump on the plane back.
That's right.
Awesome. I love this. So this is important. This is real important stuff.
Yeah, and we were talking. I mentioned a couple of times that there's a web view version or a web version of the remote monitoring diagnostic software. I just wanted to give you a couple of screenshots. It's a lot of the same things, just graphically it's represented differently. Is about the best way I can describe it. The access points, history, even some of our technicians in-house prefer to use the history feature in the web version of the software as opposed to the desktop version. It's just whatever makes people more comfortable. This is the web version. This is what it would look like if you pulled it up on your cell phone's web browser. So just to give everybody an example of that.
I love it.
And with that, I've come to the end of my discussion.
I love it. Well,
a little time for questions.
Yeah, no, I definitely we could sit here and talk for days. I know. I love conversations with you. So this is super, super important to take a look at. We talked about components, understanding the components themselves. We talked about that sequence of operation or order operation, and we talked about remote diagnostic, but we just touched the surface. There's still so much more that goes into this. And this comes with experience. This comes with research. This comes with reading manuals and books. I say it all the time. It's not always fun to read dry material because a lot of it can be dry, and that's it. But after you read it once or twice or 3 times, because it takes me a long time to learn sometimes reading, I got to read it 5 times, but then I get it. And then after I get it, I go out and apply it. And then I know a lot of us as refrigeration technicians are hands-on, but you still got to understand the theory behind the stuff you're working on so it makes more sense. And this is why I read refrigeration now and I understand it almost every time the first time, because of reading over documents over and over again. I love this, Damon. Damon, how can people find out about you, find out about Pro Refrigeration, get in touch?
So left a couple of notes. One thing I didn't have on here is we've got our website, prochiller.com. We've got a lot of good resources there. mychiller.com has a lot of technical resources, but I've got my email address here, as well as our sales team, sales at prorefrigeration.com. That'll link you right through to our regional salespeople and that whole team. If there's requests for more information or anything like that, you can filter it right there. But the email and website is the best bet. So prochiller.com.
Yeah, no, I love it. And like I said earlier, that we've got courses that we're building together, partnerships, some exclusive private training. So if you're looking to get involved in some of those, learning how to be better at CO2 chillers and chillers in general, reach out to Pro Refrigeration, reach out to the Damon, reach out to the sales team. And get involved. If you want to become better at what you do, you got to work at it. You got to train, take more trainings, come to Refrigeration Mentor and Pro Refrigeration trainings, or even other trainings. Go to the manufacturer trainings, go to the wholesaler trainings. The more training, the better. You got to be consistently learning and growing your knowledge. Damon, thank you so much.
You
really
bet.
appreciate this, brother. We'll do this again.
You bet.
Looking forward.
Thanks for having me.
Man, I love it.
I
See you all
appreciate it.
at the next Refrigeration Experts Live.